ever wanted to know anything about radiant barrier, then perk up and listen, because the next couple of slides will be directly related to radiant barriers and how they work. The first definition we'll discuss is emissivity. Emissivity is the ability of a material to absorb or emit radiant energy from its surface. This is also called emittance. So the higher the emissivity a material has, the more radiant heat it can absorb. This radiant heat most likely comes from the sun. And the more radiant heat a material can hold, the hotter it becomes. This high emissivity is the reason beach sand can burn your feet in the summer, or the inside of your car can bake a potato when it sits out in the sun. And this is also the reason your attic can reach temperatures of 135 plus degrees. You see, solar radiation heats the polarly suited black asphalt shingles in our homes in the south. The shingles absorb the solar waves, causing the molecules of the asphalt shingles to superheat, turning our attics into a great sauna. It's the dark-colored asphalt shingles that have a high emissivity, which allows them to reach the temperatures of 135 plus degrees previously mentioned. Not a very helpful material for keeping our homes cool. So why do so many homeowners associations only allow dark-colored shingles in their communities? Well, this might be a question you want to bring up at your next HOA meeting. If you do live in a neighborhood where shingle color and material are not important, you might want to consider going with light-colored, low-emissivity shingles or a metal roof the next time you replace your shingles. This will help you save money on your utility bill. Now let's talk low E. Low E stands for low emissivity. So when you refer to low E windows or low E paints, you'll know that it means the amount of radiant heat it absorbs is low. Did you know most low E coatings use metallic chips to reach its lower emissivity for windows? And low E paints that you apply to the inside of your attic ceiling use those same aluminum chips to achieve its low E rating. Some metals are excellent reflectors of radiant heat. And aluminum is the most cost-effective metal to use when trying to lower your emissivity of materials on your home. This is the reason why aluminum metal roofs, radiant barrier materials, and low E paints in the South can save you serious money on your utility bills. They keep your home cooler by not allowing radiant waves to superheat the attic and window areas of your home. Let's look at radiant barriers now. Radiant barrier materials are usually made of foil sheets or coatings that are made from aluminum and designed to reflect the sun's solar rays and retard emissions. Radiant barriers are actually the same as low E materials, but are much more effective. As a matter of fact, the best low E paint on the market has about a 28% emissivity, meaning that the paint reflects 72% of the sun's radiant heat. So, radiant barrier material would be like low E on steroids. You see, in order to be able to truly use the words radiant barrier, the emissivity has to be 3% or less. Any material higher than 3% emissivity should be called low E. Here's one quick rule of thumb about radiant barriers and low E products. These materials only work if one side of the radiant barrier material has a minimum of 2 inches of airspace. Why do these materials need 2 inches of airspace? Well, it's simple really. Aluminum is the main product of radiant barriers. And aluminum has 2 properties that are important to energy conservation. First, it's great at reflecting solar heat. Maybe that's why it sparks when we try to cook it in a microwave. But that's another presentation on another website. And 2, it's an excellent conductor of hot and cold. So, when you install material on both sides of a radiant barrier, the aluminum in the material becomes a conductor instead of a reflector and allows heat to flow through it easily. This would be the same reason why you can't cook a steak until it actually hits a hot frying pan. If you held the steak above a frying pan 2 inches, the meat would probably go bad before it actually cooked. No pun intended, but good food for thought. Also, know one more thing about radiant barriers. Radiant barriers are not an insulator. Radiant barriers only help reflect solar heat. It does nothing to stop convection heat or conduction heat. Plain and simple. This concludes the basics presented to you by CoolSouth.com. Thank you for your time, and feel free to revisit this presentation as many times as you like, or until your brain hemorrhages. And remember, always take care of the Cool South.